So the focus of this session is about incident rooms, and we have a lengthy title for that: Accelerate Incident Resolution with Faster Root Cause Analysis. With that, we'll go through the slides, and we have a short demo planned as well. So the agenda is a solution overview, and the focus is specifically on incident rooms. We have a short demo, and then we'll go to the Q&A. First, the problem statement, and then we won't spend much time here. It was addressed in other previous webinars. As you can see there, if you look at the environments where enterprises are operating under, they have various environments that they need to monitor, and there are different data sources that they need to tap to basically collect to ensure the high level of SLA. And they've deployed multiple tools over a period of time. So the challenge that we see at the NOC level, at the operations level, is that the NOC teams are flooded with alerts from these different tools incoming. And there is a lack of a command center to be able to visualize all the incidents, and most importantly, the dependency mapping between these alerts and different elements. So ServiceNow calls them CI, for example. And also, there is missing from this incident the asset intelligence. What is the actual information? The data doesn't come enriched, it comes raw. So that's something that the NOC teams are facing as well today. So at a high level, what is our approach? Our approach is to gather, to connect to all the sources, run it through our data fabric, and most importantly, apply AI/ML, provide you two different outcomes. The first outcome is operational intelligence. That's what we're going to cover now. And the second is asset intelligence, mainly on the lifecycle management of the assets, where they are from an end-of-life, end-of-sale, capacity utilization, and so on. But specifically on the operational intelligence, we are focused on alert noise reduction, mean time to repair reduction, and most importantly is to bring all these pieces together in one place. That's what we're going to, this webinar is about, is incident rooms. Our approach to this problem is not unique, but we have a few differentiators. The first one is to be able to get to the sources of data and to do the alert noise reduction. So to be able to, from the flood of information that is coming in from various data lakes where these alerts are stored, is to be able to correlate them, reduce them, and provide clustering of these information. So that's the alert noise reduction aspect. The second aspect has to do with faster root cause analysis. Being able to group multiple sources of data, provide the dependency mapping, and to be able to detect anomaly is the second pillar that we have worked on. And the third piece has to do with faster incident resolution. So this has to do with bringing together multiple teams from the gathered data, the metrics, the stack resolution, to be able to resolve these major incidents. Over a period of time, if you go through this cycle, that's when you start to see improvements on the SLA, you see mean time to reduction go down, and that's when the health of your environment starts to improve. And the last piece that I didn't talk about has to do with proactive monitoring, being able to predict alerting, and so on. Our key areas of focus are the following. The first one is data acquisition. I talked about. We have a lot of out-of-the-box integrations that we worked on. The second is asset intelligence. We focus on this because it's a strength to us, is that by looking at the assets, we're able to enrich it and provide the context when it comes as an event or as an incident to the NOC center. And thirdly, we apply huge amount of AI/ML to provide correlation and reduction of noise in the environment by naturally clustering these events. The fourth aspect has to do with incident triage and root cause. This is what we're going to be focusing on today on incident rooms. And then the last piece has to do with predictive analytics. Now let's focus specifically on incident resolution. I'm going to slow down a little bit to spend more time on incident rooms, resolution, what it means to work together in a varied environment, and so on. What does an incident resolution mean? It means that you are looking at a very varied environment, could be applications, networking, storage, security issues. And you're looking at alerts, incidents, but also metrics attached to these incidents. So this is unique to us, where we're able to connect to the sources to pull the alerts, but also the performance metrics specifically to the stacks. We also pull in logs from Splunk, Logstash to be able to bring it together in one place. And the last aspect has to do with collaboration, where you are sharing this data across multiple teams to work together to fix and look at different aspects of the same problem. How do we get started? If you are in an environment which is noisy, for example, the first thing to do is to connect to the monitoring tool, bring in the information. The first level is to do the alert noise reduction. From there, we also connect to tools like ServiceNow for ITSM to bring in the incidents that have happened in the past. So this gives us insight on what happened in the past to provide predictive next steps to be able to resolve that. I'm going to go specifically on pipelining now, how the entire process works within our system. So from the incident rooms, you're starting by receiving the alerts. That's what we call alert watch. And from there, we are able to derive actionable incidents. So that we're grouping, and then now we're telling this is something significant and so on. We pull the incidents to be able to, from the past, to see what has happened, similar type of incidents that have happened in the past, and then we're able to root cause the issue rapidly there. And then we use AI/ML. We'll demo all of this during the demo phase. Now, these are the things that are provided handily to the level 2, level 3 guys. We have what is called an automated stack resolution, because we look at not one alert in isolation, but we're able to pull the entire dependency mapping from the application down to the network and storage and say these are all the elements that are participating in this specific event or incident. We also collect the metrics that are dependent on the specific stack, and that we run also a bunch of mathematical models to see the correlation, to see if there is any anomalies on the collected KPIs and so on. And from there, we can also run some inference in terms of, is there a correlation behavior between the different KPIs? Is there any anomalies and changeable difference between what we have been able to collect to what is happening right now? So we collected the events, we resolved the stack, we collected the metrics, and we ran a few analysis on the metrics itself. Now what we need to do is to bring in the different teams. And each team have their own tools. So some teams have Slack, some teams have Microsoft Teams. For example, admins use ServiceNow for ticketing, for maintenance, and so on. Now, we need to bring the different teams in one area where they start to collaborate. And this is a two-way integration we built with these different collaboration tools, and we share the data within the different teams. We also can pull information out of other sources. This is the knowledge mining from DAC cases. If the vendor provides the API, we also can detect the changes that have happened in the same environment for these different elements that we identified. And we're able to tell you if any changes have happened recently, as well as build details. From there, what we provide to the team is several diagnostic tools to be able to run. So this could be runbook automations, tools like Automation Anywhere, but this can also be scripts to be able to collect more data, to be able to bring it in one place and make it available to the team. And then we also provide the next steps. Who is the best person who resolved this? And what was the resolution steps that they took to resolve this issue? So this is similar to what we showed you earlier. So this is what happens. When an incident comes in, the first thing is that we looked impact assessment. So that means the full stack resolution, the enrichment of the data. We look at the CMDB, but we also build the full stack dynamically as well. So these are all the elements that are dependent specifically on that incident and that CI. The second step is to go collect the metrics from various sources. So depending on the stack elements, we go to various tools that are deployed in the environment, and we collect the metrics specifically for those stack elements, and we make it handily available for resolution. From the metrics, we run a bunch of inference. Who's running together? Who's deviating? Is there any correlation between these metrics and so on? So that is done immediately as soon as an incident is identified, and then we share it with the collaboration teams. We can also have hooks into automation, like Automation Anywhere, Ansible, Python scripts, and so on. So with that, I'll jump to the demo. We have also a few webinars that are coming out. Please register, and this is basically a continuing series. We are showing you snippets of our product and offering, but feel free to reach out to us also for any demo or deep dive. With that, I'm going to jump to the demo. What we're showing you is basically the dashboard view of what the operator would see in an environment. So we're going to focus, these are alerts that were received, got clustered together. We show you the different sources from which the data came from AppD, Nagios, and so on, but also the natural clustering that happens by running the AIML. So we won't focus on these, but I'm going to focus on the incident. So after all these alerts came in, they got clustered. Now we're going to we created an incident, a series of incidents that we're going to be working on, okay? So I'm going to pick one and show you specifically how we do the full stack resolution. How do we bring together in one place? So this is an example where application performance degradation has happened on this specific URL. So that's all we got. We only got a specific from AppD, from AppDynamics, we got one specific application degradation that happened. So several things have happened now with this incident. The first thing we did is to do what is called a stack resolution. So we looked at across the stack, we said, these are the connectivity, the web services, database services, and so on. This is our secret sauce. So we started with a single URL, a single CI that sent us an event, and then we started resolving everything else from that point onward. We looked at connectivity. So these are from the application that you saw is communicating to different entities on the back end using these different ports. We also know which virtual machine this application is running on, what's its name, IP address, and so on. So the various teams can look at this enriched data specifically. So across the layers of the application stack, starting from the application communication layer, which virtual machine is running on, storage, load balancers, and so on, got dynamically resolved, and we provide it as a single entity to the operator. We also have some metrics that got collected at the same time. Because we have this stack view, we specifically go and collect the data on the metrics itself. So these metrics are not collected randomly, they're targeted to the stack elements that we have. So this includes a bunch of inference that we ran. Is there a correlation between these? Is there a noticeable significance changes in terms of from the past? Are there any anomalies and so on? So they can spend quite a bit of time analyzing this data and actually targeting specific elements of these KPIs. As well as logs have gotten collected here. So this is something we have a marker that runs across all the KPIs that tells you from the moment this incident happens, before and slightly after, we're able to collect and mark those, put a timestamp on that specific event. So why logs are critical? Because they are usually very chatty and talkative, but we have a marker that says specifically, this is where the incident happens. Go and look at the logs before. Other information that we have from the previous tickets that we have read is to be able to give you insight and next steps. How did this similar type of incident get resolved in the past? And who's the best operator who has resolved this issue? We can also see the build that happens of various software versions that got deployed within that environment. So any software changes that happened in the past in that specific environment is also flagged and identified. And I'm going to show you the collaboration tool. So this is the interesting part, is that once the data has been collected here, we can invite various teams to come and communicate, to share the same data. So Slack for security team, Jira for the help desk, Slack for the database team, PagerDuty for another team, and then ServiceNow, for example, for all the admins. The data that you're seeing here is actually shared across the different teams, and when they make a change or communicate, it's read back into this tool and shared with everyone else. The tool also allows you to run some diagnostic out of the box by integrating with Python or Automation Anywhere to run diagnostics, collect the data, and bring it back in. So for example, you can run some HTTP queries to do memory checks on specific areas within the stack. We have also ability to run some scripts to go and repair the situation where you want to, let's say, restart a server, restart a microservice, and those are also possible from the single environment. Similar to the diagnostics, we have also remediation scripts to go restart the servers. These are call-out scripts that go. One of the things also is that we put all of these in a single bundle that are exportable and demonstrable exportable and shared between multiple teams. So with that, the demo ends, and then we can start taking Q&A questions.